So we will go back to this example of conditional probability in the example of the items in a box. So 10 items in a box, 3 are bad and 7 are good. So 1, 2 and 3 are bad items and 4, 5, 6, 7, 8, 9, 10 are good items. Drawing items, and we are drawing items one by one till I get a bad item. Drawing items one by one until I get a bad item. Chance that I get one bad item in the first draw is what? Because there are 3 bad items, I'm gonna get 3 out of 10. In a good item and then a bad item would be probability of good and bad and bad. Probability of picking a good and then a bad, which is basically a probability of good and bad, will be probability of bad and good times probability of good, because we first picked up a good item and then we are picking a bad item. So the probability of picking a bad item and then a good item, so now the probability of picking a bad item after you have already picked a good item is going to be 3 out of 9, while probability of picking the first good item was 7 out of 10. So that is 21 out of 90. And this is what we keep doing it this way. We want to know this one, probability of picking a good item after picking a bad item. What about probability of getting a good, then good and then bad, which is probability of bad after picking a good item and a good item times probability of picking a good item and a good item. Again, this probability is going to be, you picked up 2 good items already, so how many? So the bad item is still there, 3, but the number of items remaining is only 8 now, and good item is also the first good item would be 7 out of 10 and the second would be 6 out of 9. So this is the repeated applications of conditional probability formula, which goes by this, that probability of A intersection B intersection C, probability of A and B and C is probability of C given A and B times probability of B given A times probability of A. So C given A and B given A and then probability of A. So this is just the called as the repeated applications of repeated applications of conditional probability. And let's look at a example of this. Suppose an ordinary deck of 52 cards containing 4 aces is divided into 4 hands of 13 each. Determine the probability that each hand has an ace. Probability that each hand has an ace. So probability that first hand has an ace, let's just say that probability that the first hand has an ace is A, second hand has an ace is B, third hand has an ace is C, and fourth hand has an ace is D. Now we can solve this with conditional probability. For all 4 hands to have an ace, thus A and B and C and D will be equal to probability of A times probability of B given A times probability of C given A and B times probability of D given A and B and C. So now we will do this. What is the probability of A that one hand has an ace? So there are 4 aces, so we are choosing 1 out of 4 and we are choosing the out of the remaining 48 cards we are choosing 12, and of course the sample space would be 52 times 13, or 52 choose 13 plus. Now we are thinking about probability of B given A, that we have already chosen 13 cards have been removed. Now we have 3 aces are left, 3 choose 1, but now the total cards remaining are 52 minus 13 minus 4, that is 35. No, that is minus 1, that is 52 minus 13 but we already took 1 out of them, so the remaining cards which are non-aces are going to be 36 and we're choosing 12 from them, and this is now only 39 choose 13 plus. Now we have 2 left, and how many cards are left which are not aces? There are only 24 left and we're going to choose 12 from them, and that is now 26 choose 13, and finally it's going to be 1 anyways because there is only 1 card left, so it has to go into the 4th one. So this is how you will do the repeated applications of conditional probability.